Hello everyone, and welcome to our lesson on how to design an off-grid solar power array wire configuration. In this video, we're going to explore how to plan and configure the wiring for an off-grid solar power array step by step. Whether you're setting up a small cabin system or a larger remote installation, understanding the fundamentals of wiring configuration is key to building a safe and efficient off-grid system. Let's dive right in. Before we begin, it's important to understand that an off-grid solar system operates independently of the public electrical grid. This means that every component, from the solar panels and wiring to the battery bank and inverter, must be designed to work together seamlessly. Today, our focus will be on the wiring configuration, which plays a crucial role in system performance and safety. First, start with your system planning. Begin by determining your overall energy needs and the specifications of your solar panels. This involves calculating the total wattage required and deciding on the voltage and current parameters for your system. When planning your array, you'll need to choose the proper configurations. In a series setup, voltages add together while the current remains constant. In a parallel setup, the currents add while the voltage stays the same. Both methods have their advantages and affect your system differently, so choose based on your energy requirements and the layout of your installation. Once you've decided on the configuration, the next step is to focus on wire sizing. Selecting the correct wire gauge is critical. It determines the amount of current your wiring can safely handle and minimizes voltage drop. Voltage drop is the loss of voltage over long cable runs, which can reduce the efficiency of your system. Use wire sizing calculators and consider factors like the distance between panels, the charge controller, the battery bank, and the inverter. Always allow for a margin of safety in your calculations. Now, let's talk about creating a wiring diagram. Sketching out your system helps visualize the connections and identify potential issues before you start the installation. Mark the placement of each component, where your solar panels will be mounted, the path for the wiring to the charge controller, and the connection to your battery bank and inverter. This diagram becomes your roadmap during the build, ensuring that every component is correctly connected and that the layout adheres to safety standards. A key component of a safe wiring configuration is the use of overcurrent protection. This includes fuses and circuit breakers, which prevent excessive currents that could damage your equipment or create a fire hazard. Position fuses at strategic points, for example, between the solar panels and the charge controller, and between the charge controller and the battery bank. Make sure these protective devices are rated for the current levels in your system and check local codes for any specific requirements. Another important consideration is grounding. A properly grounded system not only protects your equipment from electrical surges, but also enhances overall safety. Ensure that all metallic parts of your system are grounded according to recommended practices and local electrical codes. This step might seem technical, but it's essential for reducing risks and ensuring the longevity of your solar power array. Let's look at a practical example. Imagine you have a solar array consisting of several panels rated at 30 volts each and producing 8 amps. If you wire 4 panels in series, you'd have a total of 120 volts while maintaining an 8 amp current. Conversely, wiring them in parallel would keep the voltage at 30 volts, but increase the current to 32 amps. Based on your system's design, whether you need higher voltage or higher current, you'll choose the appropriate configuration. Then, Calculate the wire gauge needed for each segment of your array by taking into account the total current and the length of the run. This ensures that your wiring will efficiently carry the current without excessive heat buildup or voltage loss. It's also vital to plan the physical layout of your wiring. Consider the distances between the components. Longer cable runs may require thicker wires to prevent voltage drop. Additionally, think about the installation environment. Whether your wiring will be exposed to the elements or housed in a protected area, and choose cables that are rated for those conditions. As we move further, let's not forget about the importance of labeling and organizing your wiring. Clearly label each wire and terminal to make troubleshooting easier down the road. This organization not only saves time during maintenance, but also helps ensure that any modifications or expansions can be performed safely and accurately. Before we wrap up, here's a quick interactive challenge for you. Pause the video and sketch a basic wiring diagram for a hypothetical off-grid solar system. Include your panels, charge controller, battery bank, and inverter, and decide whether to use series or parallel configurations. Then, calculate the estimated wire gauge needed based on your layout. This exercise will help solidify the concepts we've covered today. Let's quickly recap the key points. System planning. Understand your energy needs and select the right solar panels. Configuration choices. Decide between series and parallel wiring based on desired voltage and current. Wire sizing. Calculate the correct wire gauge to minimize voltage drop and ensure safety. Wiring diagram. Sketch a detailed diagram to visualize your setup. Overcurrent protection. Incorporate fuses and breakers to protect your system. Grounding. Ensure proper grounding to enhance safety and system performance. Physical layout. Plan for cable runs and environmental conditions. Organization. Label and organize all wiring for future troubleshooting and maintenance. By carefully designing your off-grid solar power array wire configuration, you not only maximize the efficiency of your system, but also ensure it operates safely and reliably for years to come. Thank you so much for joining me in this detailed guide on designing an off-grid solar power array wire configuration. If you found this video helpful, please hit the like button, subscribe to Van in Dan Academy, and share your thoughts or questions in the comments below. Your support helps us create more educational content just like this. Until next time, stay safe, keep innovating, and happy building. Thank you for watching.